Hi everyone, good afternoon. Again, my name is Imran and I'm a cloud infrastructure architect with AWS Canada in professional services. This afternoon we'll be talking about migrating and operating Microsoft applications on AWS. I'd like you to take away three things from this session today. One, what patterns, practices, and tools does AWS offer in terms of migrating Microsoft applications to AWS? Then, how do you use infrastructure as code to build repeatable architectures? And then we'll talk about how do you achieve continuous compliance once you have, or during and after you migrate Microsoft applications to AWS. We'll do this by addressing three typical questions that get asked. First of all, why use AWS for Microsoft applications? And secondly, what are the migration accelerators? We'll talk about the landing zone in that context as well. And as well as how do you move fast and stay secure? Because you're migrating at a very fast pace in the cloud. How do you stay secure while you're moving fast? Quick show of hands for me. How many here are running Windows workloads in the cloud in general? Any cloud provider? Okay. Of those who raised their hands, how many are running or are willing to admit they're running it on AWS? Good. So from a quick calculations, here's the results from your survey I just did. I'm just joking. This is a survey that IDC did for covering 2017. Of all Windows workloads running in the public infrastructure as service cloud, AWS accounted for 57.7% of those workloads. And IDC also noted that this market is growing as enterprises are actually moving their Windows workloads into the public IaaS market. And from the AWS standpoint, we have seen growth in the enterprise at 400% as of November of last year in enterprises running Windows workloads on EC2, our compute. So pretty significant numbers there. So why customers use AWS for Microsoft applications? We have the most experience in doing this. We've been doing this since, we've been hosting Windows guests or Windows tenants since 2008, more than 10 years running. We have the scale of our global infrastructure simply. We have 64 zonal collections of our data centers across 21 global regions. For those who don't know what a availability zone is, it's basically a collection of data centers which is completely isolated and independent of other zonal collection or other availability zones in that same region. They're highly connected with the high-speed, low-latency network, typically 1 to 2 milliseconds apart. So we have announced plans for adding 12 more availability zones across 4 more regions: Bahrain, Indonesia, Italy, and South Africa. So we're growing our global infrastructure as we speak. And we have 50 plus security and compliance certifications. And these also include third-party frameworks, assurance frameworks, such as ISO 27001. We have ISO 27018 for cloud security. We also have the ISO 27017 for privacy, and also ISO 9001, which primarily applies to healthcare and life sciences and aerospace and automotive. But in my opinion, and equally important, is what's on this slide, our pace of innovation. How are we innovating in the cloud space? Just to give you an idea, in 2017, we introduced 1,430 new features and services in AWS. That number last year was 1,957. And Windows workloads are no exception there. We continue to improve on this space, and that's one of the reasons why customers choose AWS also for Microsoft applications. We have 90 plus instance types across 22 instance families. We call them instance families. and as well as 40 plus Windows-specific AMIs, Amazon Machine Images, that you can just launch. Quite a few of those come with SQL pre-installed, SQL Server pre-installed. Others have machine learning models already installed in them. And in our marketplace, we have 700 plus listings of our software, Windows software, listed in our marketplace. So you can pick a solution and just launch it. So now that we've talked about why people use, our customers are using, picking AWS or Microsoft applications, let's talk about what are the migration accelerators. So migration is really a journey, right? And here at AWS, we have a very well-defined plan or one well-defined process to help you through that journey. We begin by doing a migration assessment where we not only look at your current infrastructure and where the gaps exist, but also help you with the cost component, where you can build a business case for your stakeholders. That comes in the form of discovery report as well as a TCO analysis. In the migration phase, which is a much longer phase, we actually help you design plans, detailed plans around each of your applications by rationalizing them and looking at each of your applications, and help you build, design and build solid foundation, a core landing zone. We'll talk about the landing zone quite a bit in this session today. And then it's off to the races for a full-scale migration. But what happens sometimes is there's a gap between the MRA, which is the assessment piece, and the migration piece, with the planning piece, because maybe customers are not comfortable yet. They don't have enough data, or they just don't know where to start. So we've designed a few accelerators, MRP or pre-MRP accelerators, to help customers through that. And those come in the form of briefings, where we go through cloud economic briefing. We have a migration governance briefing. We also have workshops around how to build your centers of excellence and operating models, for example. We have immersion days, and we also have workshops around security to help you guys build those infrastructures and models. With the last two, the security and infrastructure and security and landing zone, we actually get deeper into the technology and get our hands dirty with our customer to get them comfortable with the technology. And our experience has shown that this approach has helped our customers going into the MRP phase with successful outcomes. Now, in this session, I'm going to concentrate on the landing zone and how it accelerates, in reference to how it accelerates the migration. And then we'll talk about how you can leverage the landing zone for Microsoft applications and deploying Microsoft applications. I'm going to the next few slides, build out our network infrastructure, and then build out our Active Directory infrastructure. So basically, it's a fully automated solution that we have. Basically, when you run the automated scripts in the landing zone, it creates a core account structure. At the very top, you see AWS organizations. I hope you guys can see it clearly here. AWS organizations, we'll talk about AWS organization in the end of the presentation, but it's a master account. We then have a security account, which really has access to every other account, the ones that you see here and the ones that do get created after we create them, in order to to monitor and action upon any events that happen, and for example, in a break glass scenario. Then we have the log archive account, single source of truth. All your logs from all your accounts, API logs, your network logs, your CloudWatch logs, all these get pumped into an S3 bucket there, and you actually, we have guardrails in this whole infrastructure to prevent it from tampering or even deleting of logs. So that's what this account is for. We'll focus mostly on the shared services account. I know shared services has a different connotation here in Ottawa, so I'm going to try to use the common services where I can. So this account has infrastructure to control egress and ingress from the internet. So we have two VPCs here. So these VPCs typically hold your third-party filtering solutions, for example, web firewalls, internet gateways, NAT gateways, your other IDS, IPS devices you can place in these. Then you also have a common services VPC, which is created to host your common services such as Active Directory, a major one in the context of our landing zone here. Also DNS, bastion hosts to get into the infrastructure, and very restricted access. And all these accounts have, like I mentioned, guardrails already built with the landing zone automation. In the middle, we drop what we call a transit gateway. I'm not sure how many are familiar with the transit VPC solution that we had. This is really a successor to that solution with a facelift and a lot more functionality and a lot of scale. So basically, we drop the transit gateway in the middle and establish connectivity. It's a giant router, basically, if you can think about it as a giant router sitting in the middle. So once we do that, we create routes and we light up the internet. So we have a core infrastructure set up with access to in and out from the internet in a very controlled way. Next step is very critical for migrations, Windows migrations, is establishing on-prem connectivity. So this is in the form of either VPN or a direct connect, which is a dedicated connection, is a physical cross connect, in fact, from a facility that we go in and the customer goes in, and it's 1 to 10 gigabit of connectivity that you can pick from. You can also have sub-gig connectivity, but that you have to go through an AWS partner for that. So once we have on-prem connectivity established, in the landing zone solution itself, we have what we call account vending machine. This is where we start to spin up your accounts for your workloads, for Windows workloads, and those accounts, when they're spun up, they actually abide by the rules of the landing zone and the guardrails that are around them. So once you start spinning up those accounts, you establish the routes there. So basically, you have your core network architecture now created. Let's talk about Active Directory. Very critical for Microsoft workloads before, during, and after the migration. Let's talk about what options we have for Microsoft Active Directory. So I'm going to squeeze over the Edge Services VPC on the side. If we talk about, we would drop in the gateway, transit gateway, and then we'll zoom in on the directory services piece. So obviously, with the on-prem connectivity, one most optimal option for Active Directory would be to extend your Active Directory into AWS, meaning installing your domain controllers from on-prem domain controllers into EC2. I can see that may not be an option for some organizations. So the other option is really to create another AD in AWS, where you can install it on EC2 or use our managed service, Active Directory managed services. You can create trusts either way, depending on where your identities live. Either, it could be a two-way trust or one-way trust, depending on where your identities are. You can use ADMT or a tool like that to move your identities to AWS. If you are doing federation with SAML federation with Office 365, you can do the same in AWS. We have a better option though. If you look at, if you don't want to manage the ADFS infrastructure in your environment, then AWS SSO is a great tool. Not only it federates with Office 365, you have options for a multitude of cloud-based applications, and you can also connect it to any custom SAML applications. So those are some of the options. And if you're using Azure Connect server on-prem, you can do the same in AWS. Azure Connect services is really a successor to what used to be called DirSync. So those are some of the options you have for Active Directory. And let's talk about data now on the SQL Server side. What are your options? One is to run SQL Server on EC2. This is when you need full control over your SQL instance, as well as you have RDS option. Now, in this option, we take over, AWS takes over the undifferentiated heavy lifting that you have to do. We do the patching, we do the automated backups and all that. You don't have to worry about those things. The options for migration depend on what's your tolerance for downtime. The first option is a full backup and restore or import. You can pump those, we can use the AWS Snowball device, which is a device that you provision, we ship it to you, you put your data on it, you ship it back, we pump it into S3, and from there you can restore or import it into SQL Server on EC2 or even in RDS. But a lot of downtime involved there. The second option is lesser downtime using SQL's native functionality of always-on availability groups. The third option is an AWS service called DMS, Database Migration Services. This is another very good service, minimal downtime. The source database stays intact, and it's heterogeneous. It's not homogeneous or homogeneous, depending on where you're from. You can migrate from different flavors of databases to AWS, and from SQL to SQL for that matter. From an optimization standpoint, how do you optimize SQL to run on AWS? So SQL requires a lot of memory footprint. And what we have done is we have these drives on our new Nitro hypervisor. We have non-volatile memory express instant store drives or volumes. These are actually drives on the rack. It's one of the best options with our i3 instances in the Nitro hypervisor to gain the best performance you can get from SQL Server. And then you can also do throughput volumes that we offer to do the backups and things like that at a lower cost. I love this option of optimized CPUs. Now, since SQL Server is very memory hungry for larger databases, in AWS, it used to be where you had to pick a instance with the higher memory footprint, but along with it came the matching CPUs, vCPUs. So in this case, it's R44XL, which is 16 vCPUs and a lot of memory. What we did was we changed this to where you can actually have the flexibility to pick a higher memory instance, but only activate the vCPUs that you need. For example, in this case, and you know that SQL Server will license you based on the vCPU. So in this case, with that just small feature, you cut down your SQL licensing cost to 50%. It's a great option there. Let's talk about applications now. Excuse me. So to the MRP process, so migration readiness planning process, we help you rationalize your applications into buckets. Some are COTS applications, commercial off-the-shelf applications. You may have .NET applications, and and so we help you. You may have regulatory applications where you would require pre-approval to maybe re-architect them or something. So we help you through that process. Sorry about my cheesy animation there. We use a strategy of 6 R's, which is re-platform, re-host, refactor, retain, retire, and repurchase. We'll focus on the ones on the left for this session. Now, I'm going to build this out quickly. For the fastest is rehosting. So for your COTS applications, for example, and for some of your regulatory apps, you don't want to go through that pre-approval process or re-approval process, if you will, and you would use just the rehost option. For your applications that you want to gain cloud economies with, you can host those using managed services that we have. ECS, which is our container service. Yes, we do support the Windows containers now on specialized EC2 EMIs. So you can launch Windows containers on them. And you can actually launch those and use blue-green deployments to actually put those in on EC2, still EC2. You can also use Fargate, our fully managed ECS solution, which is Elastic Container Services. Then for the last one, if you want to, you have some batch jobs, for example, you can re-architect them. In refactoring, you're actually changing the core architecture of the application. With re-platform, you're not really changing the core architecture of the application. You're just putting on a different platform to gain economies. For example, we have Elastic Beanstalk, or we have what I mentioned, RDS, which is Relation Database Service. You can use those to gain those economies. All right. And also we have a Migration Hub service, which is really an end-to-end view of your migration, from discovery all the way to tracking how their applications are being monitored, even with tools that sit outside of the Migration Hub. I just wanted to highlight this in terms of how it can help you accelerate your migration by having good tracking on the entire process. All right. From a migration accelerator standpoint, there's a whole bunch of tools on this slide, partner tools. I'm going to highlight the ones that AWS has in this portfolio now. You may be aware that we just purchased or acquired TSO Logic, as well as on the discovery side, and in Cloud Endure on the migration side. I'm going to single out Cloud Endure for 2 reasons. I like it. Number 2, I like it. I'm just kidding. It's a great tool. We also have our own service, server migration service. But I'm using this today for an example. In fact, I was courageous enough to do a live demo. I'm going to do a live demo for you guys. So help me God. We'll see how that goes. But you can migrate from any source and minimal downtime. And it's basically, it works the way where you set up your application settings, and then you install an agent on the source machine. It could be database servers too. It creates staging area in the target region, or the target VPC, or an account for that matter. And then it synchronizes. You can launch an instance from that with a blueprint in that target architecture. That would be your target VPC, for example. And it's very quick. So the staging area, and then it really launches in a matter of minutes, regardless of the disk size. All right, who wants to see a demo? Are you guys with me? All right. Can we switch to the demo, please? All right. So I'm sorry, if you could switch back one more time. Sorry, I forgot to cover something. This will be confusing. Can you switch back, please? Before I go into the demo, let me cover what the demo covers. It will be easier. So what I've done in this demo is created source VPC with the public and private subnet. In the public subnet, we will actually have a ASP.NET online bookstore, very simple ASP.NET application. We have the remote desktop gateway, the way I get in. And I have in the private subnet Active Directory and SQL Server and DNS pointing to the application right now. Now, I have established always on because for the time purposes, that was the quickest option I had, and a great option too, this native functionality in SQL Server, always on availability group to replicate to a secondary in the same infrastructure I've set up on the other side. And the transit gateway connects the 2 VPCs. So what I'm really trying to do here is simulating an on-prem infrastructure where you connect it with a VPN or a direct connect to your infrastructure on the other side. So once we do that, I'm going to use Cloud Endure to actually move or migrate the web server to the target infrastructure. We'll point DNS to it and make sure the application is working. And then we'll fail over completing the migration when your master database has actually failed over, and you can start to build upon that SQL infrastructure. So that's basically how it looks like from a demo standpoint. Let's go do it. Can we switch back, please? All right. So what I'm showing you here now, I hope it's big enough, but I'm going to zoom in a little bit. So here's my source web server, and you can see it's running on IIS, and I'm going to zoom back. It's pointing to a SQL server with the IP address with the connection string here, which is right here. This is the source side. If you look at the SQL server itself, you will notice that there's always on availability established. It's synchronous commit. My books online is my database in this SQL server, and it's been replicated to the secondary in the second VPC that I created. So I've created those VPCs, and the replication is happening fine. And what I'm going to do now is, since we have the web server looked at, I'm going to switch over to the application and show you how application is working. So here's the URL for the application, booksonline.aws-proserve.com. And it's a very simple web application. You can browse to it. You can, there's authors, there's books. You can actually go in and edit details of an author. This is going to be making changes to the the database, underlying database. So I'm going to change the code here to maybe 777 and save the changes. So it's an online database which actually is interacting with SQL in the back end. Now what I'm going to do is I'm going to use a tool that I like, if you guys don't know by now, Cloud Endure. So let me show you the console. In the AWS console, I have all this infrastructure running with the source web server right here. So it's a source web server. I have a previous implementation on when I was testing, but that will be replaced. Once I do another application, that server of this instance will actually get replaced with a new one, and we'll see that. So if I go to Cloud Endure, my machines are listed here, and here's my web server. It's in the staging area. Remember those boxes? It's in the staging area right now. What I'm going to do is define parameters. So it knows my source, everything that's running in that source. The blueprint actually allows you to place it where you want to place and define what kind of machine it's going to be. So I'm picking pretty much what I had in the source side, which is a T2 large. It's an on-demand, which subnet VPC it's going into as a target. Security groups, which is our stateful firewall. So it's going into there. And I'm going to assign a private IP address customized. You can do random one too with the DHCP. I'm doing it because I'm going to connect to this instance through our remote desktop gateway, just avoiding that step of reassigning it. And then I'm going to assign a public IP address to it, an ephemeral IP address that AWS assigns to an instance. And then we'll put that address in DNS. So this is where you actually, let's tag this differently. So May 15th, demo. I'm going to save this blueprint, and I'm going to actually launch this machine. So this will take about 6 to 8 minutes. We're not going to wait 6 to 8 minutes just, like that. So once I have this machine launched, you can see it's updating the status in progress. So while this is happening, while that's cooking, we'll go back to the presentation, and we'll cover a few more topics, and we'll come back and do the rest. Sounds fair? All right. All right. So we talked about why why AWS for Microsoft applications. We talked about what are the migration accelerators. Let's talk about how you can stay secure and move fast while you're moving fast, actually. The answer is in infrastructure as code, CloudFormation. It's a service. In fact, the landing zone solution itself uses this service extensively. It's basically JSON or YAML-based templates which interact with our CloudFormation service, and then you create a stack set of resources. And CloudFormation and the stack set is service aware, event aware. So for example, it has rollback capabilities as well. So if you were to assign it something, for example, elastic IP address, I've run into the situation, that's why I'm sharing it. If you create an elastic IP address, there's a soft limit of 5 that you can, EIPs that you can create in an account. It will stop there and roll back and give you the error codes and error that you need to fix that before you go. So it's all service aware. There's many other examples of that. And so that's one way you achieve compliance at a very massive scale. One other thing, we've talked about the landing zone. I'm talking about AWS organization. Remember that top box we saw with AWS organization in the master account? This is why we have this service. So as AWS grows, and within an organization, especially larger organizations, you begin to see accounts sprawl like this. Different departments, different groups, different functions, they start to begin deploying AWS. Since it's so easy to just spin up an account and start using it, you run into this problem, not only from a cost standpoint, but also a security standpoint as well. Billing is almost unmanageable in this kind of scenario. So we have an answer to that, which is AWS organizations. Basically, you can take all those accounts and kind of organize them into OUs, organizational units. So you have a good organization. You can have central billing, you get all reporting up to a master account, and you can address billing that way. And then, not only that, you can organize them and centrally bill them, but you can also put what we call service control policies on those accounts, on those OUs, I'm sorry. So these policies dictate the accounts that are in that OU, they have to comply by those policies. There are typically white and black lists, what an account can do and not do. For example, services, you can prevent it for using certain services if you could. Types of services, types of instances, and also you can share resources across account if you needed to. So, and then you have the problem of the central billing also resolved with this. So many features, and the icing on the cake, the tool is free. There's no cost of using AWS organizations. So that's one answer to how we do account governance or governance at scale, how we move fast. And if you have this infrastructure set up, you will be just spinning up new accounts in those OUs, and you would have to because the landing zone would not allow you to put accounts elsewhere. The other thing is identity and access management. How do you do it at scale? I mean, if you have a few accounts, you can always obviously do cross-account roles. You can set up roles on your account and give people in the other accounts assume role permission, then they can go interact with your services and play with your services and manage those services in your account. But how do you do that at scale? Answer again is through CloudFormation. You can have a stack set which defines your security templates. Sorry about the cheesy animation again here. But you define that, and in fact you can also integrate it with your CI/CD pipeline for your software deployment. You're actually managing your infrastructure and your security through your CI/CD pipeline. You can use Visual Studio for that if you want, Eclipse or other tools that you use. So that's how we do IAM at scale. Now, one approach in the past has been, when you deploy infrastructure, you do a security blessing, the security department does blessing on it, and then you're off, right? I mean, there's no continuous effort in keeping it up to date. Not so much in the cloud. You cannot get away with that in the cloud. The compliance and security has to be continuous because bad guys are always there 24/7 and they're attacking you 24/7. And one of the biggest components is the cloud infrastructure is so dynamic. You're building things up and you're tearing them down. And there's opportunities for these guys to get at it while it's being built. But when you have appropriate controls placed in there, and I'm going to single out, we have many other security tools in our portfolio. I am singling out guard duty here because it's deployed as part of the landing zone. That security account on top, that actually has a security group guard duty master role actually installed in there. And only limited people have access to those two accounts, the log archive account and the security account. That's how the landing zone controls everything in terms of how we detect. Now, guard duty itself is a threat detection service we have. It uses machine learning, integrated threat intelligence, and anomaly detection to predict and prioritize your security alerts, and you can action upon them. So, great tool. And these lines of codes are just rules. I'm here to just intimidate you guys, basically. So that's pretty much how you control or do compliance at scale. And the landing zone solution allows you to do all that with the AWS infrastructure and the Microsoft application that you move into that infrastructure. All right. So I've talked about why AWS, talked about what are the migration accelerators, and we just covered how to do security at scale. Now let's get back to the demo. Let's go to see if the machine is up. Can we switch to demo, please? Okay, very good. Okay, let's see if that finished. So I see that it's still running in the background, or the process is still running. I think I covered the material too fast. Since I have some time, any questions you guys want to ask? Go ahead. I can check for you. I think as of now, I'm going to have to check for you if it's available in the YUL region or not. Good question. I'm sorry, the question was if guard duty service is actually available in Canadian region, the YUL region. Okay, it seems like the replication is done. And I'm going to switch over to the console and refresh it. So if you noticed, here's the source machine, and it terminated and created. I can barely see this. Okay. I think it hasn't shown up in the console yet. Oh, right here. Sorry, right here. May 15 demo. So the machine has been synchronized. It has been deployed to the target region. Now we're going to go get at that machine. First thing I want to get from that machine is public IP address right here. What I'm going to do now, let me zoom out of this quickly, please. Sorry. And I'm going to go place that address, I believe in DNS, just right here. So this is my Route 53 DNS. I have my zones here. I'm going to pick out. So this zone right here is the target zone. The one below is actually the source. So I'm going to update the IP address of this machine there. Oops, what did I just do? Copied a little too much. Okay, seems like the IP address has not yet been assigned to the machine. I thought I saw that. There it is. All right, let's go back to our DNS and see if you can assign it there. There you go. So I'm going to save this record set, and I'm going to go back to my desktop here. Sorry about that. All right. So now I said that the IP address has been assigned. Remember, I kept the private IP to the same IP. So I'm going to connect to this machine to the target one. I think it's not ready yet. Yep, 169. All right. And that's what it had picked. Yep. Okay. What we'll do is, we'll let that cook there, but what we'll do is go to the database though. Let's go to the database. We'll do the database first and see if the machine comes back, and we'll do the web server switch afterward. So from a database standpoint, if I go to our SQL server, what I'm going to do is force a failover. I'm going to fail over to the secondary. Connect to it first. All right. So our database has moved over. We actually did a migration of database from a primary to a secondary in the target region. Now we want to see if this machine is up. There you go. It just took some time. I finished my content a little bit earlier, so that's why it had not completely finished. All right, seems like the machine is up. If I look at the connection string, remember, let's go back to the part where it's checking. So if I switch my DNS or my URL to so remember, this was my target URL for the target application. Let's see if it comes back. Okay, just erroring out because we have moved the database, but since we replicated the source machine, it still has the IP of the secondary, which is not read-only, which is not even read-only. So what I'm going to do is switch the connection string on the target side to point it to now the new master. So the IP of the new master is 0.71. So I've changed the connection string to the new master, the migrated database. Whoa. That wasn't planned. All right, while I wait for this to come up, any questions I can answer? Sorry, go ahead.
So how do you deal with the relationship between the local Active Directory, where everyone is implementing their models, with the new solution?
So this, are you talking about in particular this one?
When you migrate workloads, you want to be sure that only the right person will get access to the right database.
So you can do it several ways. We covered a few ways of doing it. You can do it through federation also. We can do it through SSO as well, AWS SSO as well. So what you do is you create your identities unless you migrate them using ADMT or something, you can actually create your identities in AWS, in AWS Managed AD, and then you can use AWS SSO to actually map those to AWS roles. And that way you manage your AWS infrastructure using that managed AD. So roles in that AD. So you can map it that way. Or you can also have a trust, right? I mean, you don't have to use AWS SSO. You can also use a trust from your on-prem identities. So there's several ways of how you want to connect to those between those two ADs if you have not extended your on-prem AD. Does that answer the question? Okay, good. Okay, I'm going to now change it again. Hopefully it won't reboot again on me. Sorry guys, I'm a blind person here. So I'm pointing it to the new master now. Save. All right. Now let's go check our application. So remember it errored out. This is the target URL. This is the target URL that we defined in DNS. Now we're going to see if it works. I'm going to the home page first, and voila. So you've actually moved your web server, application server, to the target region. You failed over your database to the target region using always-on SQL always-on groups, availability groups, and now you're pointing to the new target system. So essentially migrating the whole application. Now you can, basically stop the website and the SQL server, if you will, on that side, and you can start build out your SQL infrastructure in the new environment, the always-on availability groups, or if you want to use different kind of mechanisms to do that. So can we go back to the slide? I think I don't have any more slides, so I think that's pretty much it. Many accelerators to help you migrate Windows applications. I've just covered a few tools with you. There are many other migration tools that I wasn't able to cover here. SMS is one of our services. It takes Hyper-V or VMware images. There's a connector. You can actually connect it to vCenter, and it's also a tool that does synchronous replication. And you can actually create application groups, and there's many third-party tools too, as I shared with you in that one slide. Many options to migrate, and you saw the reasons why you would run Microsoft applications on AWS. Thank you, I appreciate it.